Thanks everybody for joining today. Excited to talk to you about this subject, one that I think is really, obviously been a hot and transformative subject over the last 5 years, but really over the last couple of years, we've seen DevOps cross the chasm. We saw over the last decade, we saw open source cross the chasm. So we're going to talk a little bit about, where's the history of all this? Where did it all come from? And then really, where is it going? What's next? What comes after DevOps? Because we're certainly not done. There's still plenty of friction and toil and frustration left in the development process. So what comes after DevOps? We're going to talk about that as well. As Javi mentioned, my name is Justin Reock. I'm the Chief Evangelist and Field CTO for Gradle. My background is in software development. I wrote code for a long time. And then worked as an enterprise architect and ran a team of enterprise architects. Worked for a company you may have heard of called OpenLogic. We were very active with the open source 101, as well as the all things open community. Big fan of these shows and events. Love Todd, wonderful guy. Such a great program that you're participating in right now. Really just one of the best software and open source shows out there. So I'm here to talk to you today. At Gradle, we focus on developer productivity. We have our open source Gradle build tool, as well as our commercial Gradle enterprise product, which focuses on a practice of developer productivity engineering. And it all came from DevOps. But let's go back even further. Let's dig into what I like to call the ancient business wisdom of the 1970s and 1980s. When things were definitely different, but a lot of the rules for business productivity were the same. I should say a lot of the constraints were the same. Manufacturing and production was sort of king as opposed to software as it is now. But a lot of these principles would apply. So some of you may be familiar with this book called The Goal. It was written in 1984, published in 1986. It is required reading in a number of MBA programs, still considered by many to be one of the best bits of business literature ever written. It's a business fiction, so it's not like a playbook style handbook or anything like that. It's a novel about a fictitious company, a manufacturing company, struggling to keep pace with the competition. And it's about a change agent coming into the company from the board and introducing lean manufacturing principles and the theory of constraints. And it introduces these principles to the business. And, spoiler alert, it all works. The business becomes more productive. They're able to increase their throughput, decrease their cost. And this is effectively the story of that business. So we talked about The Goal is not like a business reference book. It's a fictional account of a business that adopts lean manufacturing principles and business rules according to the theory of constraints. Now, Goldratt was a physicist, not a business person. He studied complex machinery, complex mechanics. And the theory of constraints is effectively a method of coming up with the base parts of a complex machine and talking about how they interact and work with one another and how friction and bottlenecks can keep the machine from operating at its peak performance. And all Goldratt really did was turn around and apply the physical traits of the theories of constraints to businesses, right? He just made the intellectual leap to say that businesses are also complex machines. And so they will be subject to theory of constraints. And all of this stuff that we know of now, DevOps, Agile, would extend from this idea, this theory of constraints idea. If you're not familiar with The Goal, you may be familiar with the Phoenix Project, published by IT Revolution. Spafford, Bear, and Kim worked on this one. If you read the opening to the Phoenix Project, they're very clear about the roots of this book being in The Goal, right? The Goal was the inspiration for the Phoenix Project. Give me just a moment. I'm going to pull up my participant window here. As Javi mentioned, if you have any questions along the way, feel free to just do the hand raise or type something into the chat. I actually really prefer to work that way. It reminds me that there are actually human beings on the other side of this. So feel free to just raise your hand with questions. So again, not familiar with the goal, you may be familiar with the Phoenix Project, very popular book within software circles, and it effectively modernizes the theory of constraints for software organizations. So a lot of what the theory of constraints talks about, and we're going to get into this, is the conversion of inventory into throughput for some sort of cost, right? And that's the core of the theory. And the idea is that if you can increase your throughput and decrease your costs, that whatever you'll do is actually better for the business, as long as it can do both of those things. The Phoenix Project says, okay, well, why not take the lessons that we learned from the goal and apply it to a software organization instead, right? And instead of having a change agent who comes in and introduces lean manufacturing, like in the goal, instead we have a change agent who comes in and basically introduces Agile and DevOps to a fictitious software company called Parts Unlimited. This is a great read. I highly recommend this book if you haven't read this before, and if you're interested in productivity, or really if you just work in software. I believe everyone should read this book. It will change your perspective on the way that you work and the way that your value relates to the business. And it teaches the importance of these modern DevOps practices that are being adopted, like value stream mapping and value stream engineering, observability, continuous improvement. Another great one, going back to the 80s again, The Machine That Changed the World, the story of Toyota. This was the story of how lean manufacturing was able to bring Toyota, sort of a nothing car company at the time, to compete with some of the biggest auto manufacturers like Daimler, and how they won, right? And it's constraints-based thinking. Lean manufacturing has got a very interesting history as well. It was, post World War II, Japan was forced to manufacture and keep pace economically with less, just simply with less. And so they would come up with a lot of these lean principles that would then become codified into Western and American business. All right, so what is it all about, right? What is the shift in mindset for DevOps, for lean manufacturing? Well, it's a change in focus. It's a change in the way that we think about a business. Now, typically when we think about business, we think about businesses having costs. All right. We think about the cost centers of our business. We think about the employees that we have to pay. We think about the energy that has to go into manufacture. And so our focus then has been traditionally thinking about a business as cost. Now, what are some symptoms of that? Well, layoffs, that's a big one, right? Kind of the textbook one. There's a notion that if we want to control cost in an organization or in a business, that we have to lay people off, right? We have to fire people because that's our big cost center. That's what costs a lot of money in the business, or people. But the problem with just having a layoff is that if you're not also increasing your ability to push product, well, then it doesn't really matter that you've decreased your cost, because you're not producing any more product. Previous to, sort of agile thinking, lean thinking, any of these things, thanks, Adele. Yeah, we're trying our best. So prior to kind of agile thinking, theory and constraints-based thinking, most businesses are cost-based in the way that they think about how they shape their business. And so going back to what I said before, what's a big symptom of this? Businesses think that they can solve problems by laying people off because it decreases cost, but it doesn't increase throughput. Throughput is the rate at which you're actually producing materials that you're able to sell, right? Throughput's money in terms of a business, right? These terms are meant to be generic terms for the theory of constraints as it relates to a complex machine. All right. Complex machines have inventory, there's an energy cost, and then the machine creates some kind of throughput, right? It does its job, right? It processes something or whatever it is. A business has these three has these three elements as well. But in the business, the inventory is the raw materials. The cost is the cost, the energy, the human cost, whatever. And the throughput is money. Okay, the throughput is money. And why is the goal called the goal? Because the goal of a business is throughput. The goal of a business is to make money. Okay, so you can't decrease your cost only and expect your business to succeed. You have to take measures that decrease cost and increase throughput. Decrease the cost of the machine, increase the output of that machine. If the business action that you're about to take, if the strategy will do both of those things, then it's a winning strategy, right? And it's a very great framework for checking yourself as to the strategy that you want to take. Is it going to do both of these things? Is it going to increase throughput and decrease cost? And if the answer is no, then don't do it. Then don't do it. It's not going to improve the state of your business, right? This is the essence of the theory of constraints. Now, this was before software. Remember, theory of constraints dates back to the 80s. So what was the intellectual leap that took us from constraints-based thinking to DevOps and Agile? Well, it's this. Think about a software organization. What's cost? Organizational cost, just like always. What's inventory? It's code. Code is our inventory. And then what's our throughput? Money. Okay, great. So what does that mean? Well, what is DevOps trying to achieve? What is Agile trying to achieve? It's trying to get your code out to market faster so that it makes money for the business faster, right? Ideally, we decrease the amount of time between merging the code and getting the code out to production, right? All these automated release pipelines or these solutions like Launch Darkly or Circle CI or Kubernetes, and Docker, the ability to package our app and then self-service deploy in real cloud-like infrastructure immediately. It's all this. It's all about increasing throughput because you don't want the code to sit around. What happens? Bit rot happens, right? Vulnerabilities come out and we have to patch the code before we can even release it. New changes come in, API breaking changes. The code rots when we don't turn it into throughput. And why? Because of entropy. Another important principle in DevOps and the theory of constraints is continuous improvement. And that's because it doesn't really matter what you improve as long as you're constantly improving something, because entropy denotes that if you aren't doing anything, you're not sitting still, you are rotting. You are actively getting worse, okay? This is why feedback is so important in DevOps and why feedback is so important in this world. And this is very common, familiar DevOps feedback loop here. What's happening, right? Everything is staying in motion. All right, the DevOps infinity loop is very intentional, right? The symbol is very intentional. Everything is constantly moving. Nothing is stagnant. There are wherever there is friction or toil or a bottleneck, you eliminate it. You scale it, you observe it, you automate it, whatever it takes, but you make sure that the loop is always moving. That's how you battle entropy. That's how you battle this problem. Now, the first time I think I ever heard this mentioned, and I see we got a question, I'll answer in just a moment. The first time I ever saw this mentioned was Uncle Bob, Robert Martin, giving a talk about DevOps and why short release cycles are so important to being able to refactor, modernize, and improve our code. And he said, we fear the code, and so the code must rot. We fear the code, and so the code must rot. What are we afraid of? Well, we're afraid of long release cycles. We're afraid of a month-long project that we release on a Friday, knowing that that means we're going to have to work overnight because the release is going to break a bunch of stuff. We're not excited about release day. We're afraid of release day. And if we're afraid of release day, then we're afraid of refactor. And if we're afraid of refactor, we're afraid of modernization. And if we're afraid of modernization, then the code must rot. Okay, so we have to keep things in movement. Adele, you raised your hand. How can you ask the question? Here we go. What is the human cost of this constant change? Excellent question. And the drive is, of course, less and less. The drive is to automate as much as possible, right? You want you want as little human cost in the loop as possible. And as we get to the end of this presentation, we talk about what's coming after DevOps, we're going to talk about developer productivity engineering, which is using technology to make sure that all of the bottlenecks existent in the developer experience are eliminated, right? So acceleration technologies for build and test cycles and things like that. So we're going to talk about that as well. It's a great question, Adele. The answer is as little as possible. And these are the questions that we have to start asking ourselves as we move into a world that is 65% digitally transformed. The global GDP right now, as of now, is 65% digitally transformed. Okay, that's 2/3 of the global product is now software. So we can't stay in this mentality of, is it good enough? Is it efficient enough? No, those are the wrong questions now. The right questions now are, is it as efficient as possible, given all acceleration technologies and all observation technologies? Because if not, you're not going to keep pace with your competition, right? No longer the big beating the slow. No longer the big beating the small. It's the fast beating the slow, right? So what does this kind of look like from a technology stack? Well, this is one example. Right? To build that CI/CD or feedback loop, you need a lot of different technology working together. This is a very Amazon version of it, but you see this stack of technologies working together to do really two things on the side of DevOps. On the one side, we want to automate as much as possible the packaging and creation of the software artifact the developers working on. So we see all these great technologies like Jenkins and Git and Terraform allowing us to do infrastructure code, and Chef through automation, and Travis or Circle or one of these other CI/CD pipelines, right? We want the developer to have all the automation that they can have in the creation of the artifact. And then, of course, once the artifact's created, we want all the automation that we can have to constantly deliver, gather feedback. You know, we're living in a world now where we have amazing like service mesh implementations where we can literally, Amazon right now can release code from the second it's been written to about 15 seconds out in the wild, use a proxy mesh to only deliver that change to a small number of weighted users. If any failures come up, it's immediately rolled back within seconds. Basically, you're just hitting refresh on your browser and you're none the wiser, right? That's automated testing in production, and it works like safely. And feedback can be gathered to inform development. And it's because of these types of technologies. But it all goes back to theory of constraints, all goes back to, are we increasing throughput and decreasing costs? And are we doing that through automation and through better infrastructure? So there's a lot of technical actions that you can take to be more DevOpsy, right? There's not one thing to make your organization a throughput-driven organization. There's lots of things that you can do. So getting into talking about open source, choosing free software without deployment limitations or any constraints to accessibility, this is so theory of constraints friendly, right? Open source and the phenomena that is open source is probably, I would say, the most constraints-friendly phenomenon that's happened in the last decade that's really accelerated the industry, really lifted all boats. And that's because of its accessibility, right? It has nothing to do with the fact that there's not a license cost available. It's everything to do with it. There's very little toil or friction involved in getting your hands on the software, right? 10 years ago, it was hard to be a developer working on mostly commercial platforms. You had to deal with procurement. You had to deal with licensing. If you wanted to do your job, you had to rely and wait on other people to procure software licenses, on system integrators to stand the software up for you because there's proprietary ways that it had to be installed. It could be weeks before you're even ready to start a project, just because you have to wait on all this commercial infrastructure to be available to you so that you can have the tools that you need. Now, living in an open source world, we have the most powerful software available to all developers in a totally equalizing fashion without financial barriers or any barriers, really. You can just go access the software. You know, has that created a whole new subset of problems and management and governance? Sure, of course it has, but it's also accelerated the pace of innovation like no other phenomena the software industry has ever seen. So choosing free software and an open first mentality in your business is a great DevOps technical action. Deploy in cloud or container substrates with choreography. There's no reason not to do this now, right? And as we get into 12 factor and we talk about 12 factor, we'll see about the roadmap to actually getting your applications ready for this. Viable API management solutions. You must have an API management solution. All of this layer is going to become your microservice, the front end to your microservice infrastructure. And that API management is going to be critical to making sure that everything can access your code, but also organize it. And then building a fail fast culture, right? Don't ever roll back a release, right? I know that sounds weird, but the loop must always continue in this direction. The conveyor belt must always continue towards deployment. If you deploy a bad release, then deploy a fixed release. Don't roll it back. Fix and deploy again. And your automation should be in place so that you can do this turnkey, that releases aren't hard. Literally, Amazon is releasing code. They just released. They just released again. They just released again. They just released again. Amazon is constantly releasing code. They have the best automation pipeline for all of this. That's the mentality that you must be in. Don't roll back something that broke. Release a fix 5 seconds later. Okay, fail fast. So what does the landscape look like now? Well, it's huge. This is the cloud native interactive landscape, but you could absolutely just call this the DevOps landscape as well. These are all the different software players. This is an open source project, by the way. If you just Google CNCF Cloud Native Interactive Landscape, really cool utility that's just made available to you for free. And it's just this map of all of the enabling technologies that allow a DevOpsy cloud. And you see some very familiar stuff here. Kubernetes, obviously, right? Kubernetes sort of is DevOps realized when combined with other CI technologies like Jenkins X or any of these things. But then little players too, like gRPC. gRPC is slowly replacing REST and doing it in areas of cloud infrastructure. It's a wonderful protocol. Anything that you see on this chart that's clear, it's not grayed out, is open source. Okay, so that's why this presentation is open source DevOps 12 factor. These three things together are what's forming our very fast and modern software deployment infrastructure. And they don't work without one another, right? DevOps doesn't work without open source. It wouldn't be fast enough, right? And 12 factor software doesn't work in the cloud without 12 factor, not as well as it could. CNCF also provides this entire like cloud native DevOps trail map for you. Really a nice guide to say, what are the steps to taking our business from traditional, more monolithic deployments to DevOpsy cloud deployments? Where do we start? How do we gauge our maturity? And this is it. This is your trail guide. Begin with containerization, which will involve 12 factor development. We'll get into that. So containerizing your apps, that's a big part of why 12 factor is so important. It's a nice rubric to say how ready for a container is my app. Once you've got that in place and your app's in a container, CI/CD, obviously, you need to automate deployment, orchestration and application definition, observability and analysis, right? These are the next steps, proxy mesh so that we can do cool canary releases, security, messaging, software distribution, all the way out to the distribution channels, right? This is the roadmap to DevOps maturity, and all of this is open source. So how do we get here? Well, aside from the manufacturing wisdom that we talked about in the goal and theory of constraints and lean manufacturing, we kind of had this convergence. We knew this stuff about manufacturing. We knew that it could be done better. It just hadn't been applied to software yet. Because back then, this is in the call it 90s and even the early aughts, the reality of deploying an application was that you would go rack a server, you go buy a server, put it in a rack somewhere, it's expensive, $10,000 server, configure the operating system, install the application on it. And, this is really expensive to do it that way. Software, server hardware wasn't cheap. You're talking about $10,000 server, power, co-location fees, all of this stuff was expensive. When applications are running isolated, which they kind of had to be, right? We kind of know that application isolation is important. We don't want, business impacting critical applications competing for resources or starving each other out. or possibly interfering with each other. So these servers were really underutilized. One app was deployed on a single server. When more than one app was deployed, we talk about isolation. There could be library conflicts, and it was all just very disorganized. And in the end, it's so easy to get into the weeds of all the infrastructure, the networking, the code, the framework, but you always have to remember that the business only cares about the app. It's all about the application. It's all about keeping the app up and running. Us as practitioners who know a lot about how the backend works, we tend to focus on that, but the business doesn't. The business just wants the app to work. So we began with hypervisor and virtualization, right? We've been around for that. VMware, the rise of VMware, the rise of Hyper-V. In many ways, this virtualization is what would give birth to the modern cloud for sure. And what did it allow us to do? Well, take a physical machine, drop a hypervisor on it, and let it pretend that you have a bunch of physical machines that are able to respond to the operating system. It's just emulation. It's effectively the same technology that lets me play old Nintendo games on my laptop, right? But it's instead saying you've got a whole computer here and you can throw an operating system on it, and then you can throw the app on it. Great. That ensured much more efficient utilization of one single physical machine. Oregon Trail emulation, yes. And that's, they have new versions of that game and they're not as good. The old one is better. So I love to fire up like a Windows 95 VM and throw Oregon Trail in there and play it the way it was supposed to be. Good call, Adele. So ensures much more efficient utilization of a single physical machine. Also ensures that applications are isolated from one another, gated in the total amount of server resources that they're allowed to consume. But is this as efficient as it could be? No, still a problem. We have to install an operating system on all of these VMs. That operating system has to boot, which takes time. It takes up a storage footprint and a resource footprint that is wasted. So what did we do? We came up with containers instead. So instead of the entire virtual machine, we stripped down the file system. We have just the minimum viable parts of the operating system that are there to let the app work. It runs on top of a container engine instead of an entire emulated piece of hardware. And they're still isolated, but they're powered by one underlying OS as opposed to a bunch of different virtual machines. So now we only install the operating system once with a container engine, and this app, it's ready to go immediately. Now I know, Docker has definitely crossed the chasm. I'm sure most of you are using it at this point. But if you haven't used it, or if you have, you can appreciate that nothing boots. It's not like in a VM where you have to wait for the entire thing to boot up. Literally, a file system called an image is poured into the container space, and then it's just bootstrapped. It just runs, right? So this is ideal for the DevOpsiness that we want, the ability to elastically scale, the ability to fire up 10,000 instances of our app for 5 seconds to process some crazy workload and then bring it all back down and do it as cost efficiently as possible. Okay. So you can see here that it's this merger of the constraints of the industry and the wisdom of the theory of constraints and Agile that are coming together now to form a more frictionless way of deploying software out into production to turning it into throughput, going back to what we said from the beginning. If I can write some code, that's my inventory, stick it in a Docker container, and through automation, have it out making money for my business within seconds, that is very good throughput. That's excellent throughput, right? So what is DevOps doing? It's increasing our throughput and decreasing our cost, which we know from the theory of constraints is always going to be a winner. Great, so we're finished, right? With containers? No, not even close. The capability to run an app in isolation in a container atomically in any cloud is not free, right? Your application has to be written in a way that it can actually take advantage of these things. You've probably seen or maybe even experienced yourself what happens when you try to lift and shift a, say, VM style deployment over to a, like, say, Kubernetes deploy, right? So maybe got an app and it took 10 VMs to run it. Now I just go create 10 containers with a persistent storage volume and run 24/7 in Kubernetes. Many of you may have done that, and then you may have turned it on, and then you may have realized that, well, it doesn't really accomplish anything to do that. may as well have just left it in the VM, because if your architecture is the same, then you're still monolithic. You're not going to be able to take advantage of elastic auto scaling. So why are you in Kubernetes, right? Why not use something like Vagrant or some other, HashiCorp automation? So what you really have to do is refactor your application. You really have to refactor your app to be able to take proper advantage of containers and all of this new deployment speed. And the 12-factor process, which is totally, you just go Google 12-factor, you can see all the factors that are available. It's almost like the Agile Manifesto. It's just a website that's there as a resource. And I won't go into all of these, we don't have time, but these are the 12 factors that say, it's almost like a rubric. It's almost like a rubric for your code. How close are you to abiding by all 12 of these factors? And you can almost think of it as an inverse relationship between the amount of friction that you should expect to experience when moving your product out to cloud and the amount of 12-factor compliance that you have. There's an indirect relationship, right? So highest 12-factor compliance, least friction deploying your app into cloud. Low 12-factor compliance, you're going to experience a lot of friction trying to get your app out to cloud. It's just, you're going to get out there. You're going to have been relying on things like fixed infrastructure for configuration. Number 3, 12-factor, you must store your configuration in the environment using environment variables. The reason that environment variables have become so popular again all of a sudden is because they're easily injected into something like a Docker Compose, or even can be altered on the fly in like a Kubernetes infrastructure, right? But it has to be atomic. The config needs to live inside the unit, the app, so that you can deploy that app anywhere in any cloud, and it's totally self-reliant. So much about what 12-factor is making your apps self-reliant, right? So this is a great rubric. If you're wondering, okay, well, Justin, what do we do to get our apps ready for containers and Kubernetes and to really take advantage? It's this. This is your guideline. So follow the 12 factors. Yeah. Oh, there. Thank you. Yeah, for posting that. It's an excellent methodology, and I promise you go through those 12 factors. I mean, look at what some of these things are, right? Keep the config in the environment. Treat logs as event streams. All right, we're all doing this now. Elk, FluentD, Splunk, right? We don't go and log into a machine and go hunt down the logs anymore. The logs get pushed out from the app so that the app can again live anywhere, but push log data out to somewhere central, right? Disposability. Right? The app should be able to start up, shut down, and leave nothing lingering, right? That way, we could start it up 10,000 times across 12 cloud regions and fire it all back down. And we don't have anything lingering, right? So again, we won't go into all of it, but 12 factor is so important to being able to do DevOps the right way. So now we've actually created a need for a whole ecosystem though. Given that we've got containers, they're living inside of virtual data centers now. We're going to have to give them access to networking and storage and manage their lifecycle somehow and orchestrate and everything else that goes into building a data center. So what did we do? Well, we invented Kubernetes. Oh, thank you, Javi. I know we're getting to 5 minutes. We're going to go another 5 minutes over. That's great. And I think we should be pretty good here actually on timing. So Kubernetes. Right? Google had a need for, one of the most 12-factor companies ever had a need for all of, the ability to create this virtual data center that followed their DevOps principles. Nothing existed. They had, Docker was around and other container formats were around. Containers have been around for a long time. Even Solaris zones or BSD shrewded jails could be considered containers, but there wasn't something that could orchestrate it at the scale that Google really needed. So they invented Kubernetes. Which is not a traditional all-inclusive PaaS framework. It does not dictate application frameworks, doesn't provide any middleware for you. You have to bring all of that. Doesn't deploy source code, does not build your application, doesn't dictate the logging, monitoring, and alerting systems, but it does provide a full framework for running a data center in a box, right? And it absolutely was born of necessity, right? Google came out with this because they needed a software platform that could effectively realize everything that they wanted to be able to do with their DevOps friendly code. So what is it? It is an open source platform for automating deployments, scaling operations of application containers. Docker is certainly the most popular one, but it's not the only one that's supported. There's other container like Containerd, Cryo also supported. It allows you to deploy quickly and predictably, scale on the fly, seamlessly roll out new features, optimize use of the hardware by using only the resources we need. And it's really an ecosystem of solutions now that work together to form sort of a fully realized virtual data center in a box, right? So Kubernetes is very DevOps friendly in the automation, orchestration aspect. But you can't just go to Kubernetes. There's, again, the 12 factors are very important here to refactor your application so that it can actually take advantage of all of this. And again, it's changed the way that we write software. So again, revisiting the 12-factor app, this is the recommended set of coding practices for making sure that your code is atomic and can work well across multiple clouds. I mean, that's really what it is. It's, can I take this application, drop it in Google Cloud, drop it in Azure, drop it in IBM Cloud Private, drop it in Amazon, and it's just going to behave the same way consistently no matter what across all of these. I can observe it. It's going to send its logging data to the right place, right? That's all of these. That's all of the goals of trying to 12-factor your app. So Javi already posted the link, but just in case you missed it in the chat, here it is at 12factor.net. Wonderful resource. And yeah, you really can just use it like a rubric. Just take the code that you're trying to refactor for DevOps or for cloud and take it through the factors and just be honest with yourself about how close you are to actually achieving it. Okay. So we talked about theory of constraints. We talked about the goal. We talked about the Phoenix project and how that's a modern realization of the goal and introduces DevOps and agile practices to software organizations. We talked about the need to take an open first policy. How important is open source to all of this? Fundamentally important. None of this exists without open source. It just doesn't. You have to have that public, open, instant access to powerful software in order for any of this to work. So none of it works without open source. How do you take great advantage of these new DevOps, this new DevOps mindset and philosophy? You do it through 12-factor refactor of your applications. So hopefully after this talk, the intersection between all three of those things is evident to you now, that between open source, 12-factor development, and DevOps, the pace of innovation is 10 times what it was. The pace of innovation in the entire industry is 10 times what it was, right? As a result of this. But what's going to happen next? How about after DevOps? Are we done eliminating all the bottlenecks and all the friction and all the toil? No, we're not. We have to keep marching left, okay? Now, DevOps has solved a lot of problems for us in terms of our ability to better observe, deploy, and automate moving our code out to production. It's not focused enough on the developer experience, all right? Too many developers still sit waiting sometimes hours for builds to complete, only to see the builds fail. And then they've got to go spend a bunch of time troubleshooting them, right? Software development is a creative process. And when you interrupt that creative process, you interrupt happiness and you interrupt productivity, right? So the next thing after DevOps is developer productivity engineering. You're starting to see some companies come out now, Launchable, Orangebeard, Appsurify. These are technologies that are focused on taking an engineering approach to productivity. These are technologies that are focused on keeping developers in a state of constant creative flow so that they can continue to enjoy what they're doing instead of having to put up with a bunch of friction and toil and frustration, right? I think that it's fair to say that in a 65% digitally transformed GDP, that software practitioners and developers are possibly the most important workforce in the world right now because they lift all industries, right? They lift healthcare, they lift bio, they lift science, energy, agriculture. Everything around us is being uplifted by software. And so this is a workforce that we need to take care of, right? And the best way that as engineers that we can do this is to make the developer experience as good as possible. And that's developer productivity engineering. It's taking what we learned from DevOps and applying the same constraints-based thinking to the developer experience itself. How can we use caching, acceleration, and analytic technologies to make sure that developers can avoid running into build failures altogether? How can we deal with flaky tests? How do we get past a build that takes an hour? When we put changes in, we have to wait an hour to see if what we did was actually correct. And developer productivity engineering can solve a lot of these problems for you. So I'm just going to leave you with a link to our own learning center about developer productivity engineering as a completely free resource at Gradle, as well as our ebook. You only see Gradle even mentioned on the cover. This is a vendorless book about the practice of developer productivity engineering. We're very proud of it. Spoiler alert, we are in talks with O'Reilly. And so we are really wanting to evolve this. But right now we have the ebook available to you. And I would just, the appeal would be to go be a hero in your organization. Imagine if you were the person a decade ago who started an open first policy at your business, or imagine that you were the person who brought DevOps into your business 5 years ago. What would that have done for your career? Where would you be right now? And what would you be working on in terms of value? I would challenge you to take the same step with developer productivity engineering. It's so new. Even Netflix only started this process maybe less than 4 years ago. So it's still very new, and a lot of opportunity to build a career with this kind of mode of thinking. So that's it. Feel free, reach out with questions, add me on LinkedIn or whatever. I love talking about this stuff. I also, beyond developer productivity engineering, had a long career just talking about open source in general. So happy to talk about any of that stuff as well. But thanks so much for the participation. Thanks, Adele. I'm really glad you enjoyed it. Thanks for the interaction, the questions. It helps me so much to have that interaction. I really appreciate it. But I'm glad you enjoyed it, and enjoy the rest of the show.